Okay, so we are starting snow load. How to calculate snow load? Initially, we use a equation that is PF is zero point 0.7. I think. Let me see the book is 0.7 CECT IS rho G. What is PF? PF is load in PSF. Now this F means flat. Flat. What is flat means? It means at the beginning we assume our roof is not sloped, it is flat. Then considering my roof is flat, we use my snow load, we using this equation. Now what are these components? 0.7 is just 0.7, it's a 70%. What is CE? CE is exposure coefficient. Exposure. Okay, I'm not writing the exposure coefficient. What is CT? CT is thermal coefficient. Thermal coefficient. What is IS? IS is importance. Importance coefficient or factor. What is rho Z? Rho Z is ground snow load. Ground snow load in PSF. PSF. So this is the equation, very important equation, because it has a lot of parameters and everything makes sense. How? Whatever the ground snow, a percentage of this will be on your roof. That is the assumption based on the thermal, based on the no importance is just importance. It's just multiply if your structure is very important. That is importance. Now, if I go one by one, exposure coefficient. What is exposure coefficient? Exposure coefficient means how exposed your building is compared to your surrounding. Say your building can be inside Denver, very crowded. There, in that case, what will happen? When there is wind, there will be less wind. Now, if there is less wind, there will be more snow on the roof. If there is more wind, the wind will take some snow away. That is number one. Number two, on the other hand, if there is wind, there will be more snow because more snow will come. And also, if there is shelter on top of your building, a tree. If there is a tree, there will be less snow. So that kind of shelter is also important. So this CE considers both. Considers your surrounding and your top, whether there is any shelter or no. So we'll go now. How to find it? Uh, if I open your book, they gave us the table number CE from table 72. So it is ASC, not your book. It is not in your book. Table 7-2. I'm showing you. So from ASC table 72, you can find it. Then thermal factor. Thermal factor will be from ASC table 7-3. ASC. You'll find it. What else? Importance. Importance, you will find it maybe earlier, sometimes table 1.1. ASC table 1.1 at the very beginning of the build. Very beginning. Okay, I took some scan from your book. If I open it, let me see whether it opens or no. Okay, it is coming, but I can already open. But before opening, importance factor. Importance factor means how important your building is. You can like compare a hospital versus your house. It's not same important to community. In hospital, if the building like collapse, the patient cannot like run away. They will just see. They cannot do anything. So it is high important. On the other hand, a school building, lot of kids, they do not know what to do. They will just run here and there and make mess. So that is second category. Third category may be normal building, normal office building, who are mostly adult. They know what to do. They have some common sense. Another category may be, say, storage. agricultural storage, or that kind of building where there are very few people, mostly the like raw material, not so costly. If it collapse, damage is obviously there is damage, but not so much. So comparing these four category, okay, I don't know why started to discuss importance first. No problem. As I did it, I'll finish it. So you can see from your ASC, from ASC table 1.1, and they combined, and then they made a summary in table 7-4, importance factor for snow loads. You can take it from table 1.1 also. So you can see here it is summary. What does category 1, 2, 3, 4 means? 4 means similar to hospital, that I already told you. Hospital very like critical. If a building collapse, there will be so much like damage or massacre. So in that case, we will use 1.2. School type building where there are school, stadium, large assembly where there are more than 300 people. Your book said more than 300. But my logic says do not exactly count the number, use your common sense. If it is very important or less or like not important, or always try to be safe. If a school building, if you use 1.2, you'll be in the safe side. So, okay, it is now up to your judgment. And category number 2 is normal building. Normal residential building, office building is 1. There is no importance, more or less. Category number 1 is agricultural storage, silo. They will store corn, pumpkin, whatever. So if that building collapse, not a problem. Obviously problem, but not so important compared to the hospital. So that is your factors. Okay, maybe I'm talking so much here. I believe that you understood this part. Based on importance, if it is important building, your safety will be higher. So in that case, that will take care of your importance factor. So one is done, and I believe you can find it. Normal building on agricultural storage or similar, or even in your ranch where there are some animals, zero point 0.8. Normal building on school type, school building, gallery, stadium, assembly, this kind of building, lot of people, 1.1. Hospital, clinic, this kind of building, 1.2. So the story about IS is done. Ground snow next. How to find the ground snow load? It depends on the historical data. Every city has its own historical data. But ASC gave us some guidelines, starting point. At the same time, when you read the book, it will show you that always check it with your local agency, because this one is very old and very broad. And what is this? It's a contour plot of snow. Oh no, which table number is this? It is figure 7.1 in your book. Oh, not book. ASCE 7. I uploaded this in your Blackboard. If I go find where is Colorado, I do not see. Colorado. Colorado, maybe this is New Mexico, this is Colorado. Because I can see this portion is El Paso, below New Mexico. So this is New Mexico, Colorado. You can see only one line. Only one line in showing in Colorado, and that is how much. I cannot read even. Elevation. Oh, maybe my eyes is not working good. Whatever, you can see in the entire state, the snow load is given only by one line. That means it is not accurate. You know that in Pueblo and in what is the name, in the hilly area, if you go to Delta, Montrose, Telluride, in that area, snow load is huge. Pueblo not so much. Spring bigger than larger than Pueblo. If you go to Grand Junction, there is no snow. there is no small. So it changes. So we should not use this figure to design. Now then what to do? Simple. Go to, if you want to design a building in Pueblo, go to the engineering office in Pueblo. They will give you the latest. Or simple, I downloaded it sometimes last year. It is in Google. It is in Google. If you or maybe here also. Oh no, in your AC there is a table also, but that is not so accurate. The second part of this figure is the east side. Here, New York. And where is New York? Here maybe. I don't know. Here, I can see this is Long Island. New York is here. This is the tail. Tail means Long Island. Albany is somewhere here. Buffalo is somewhere here. Okay, so you can see there are so a lot of data is given. Say Buffalo close to Niagara Falls is 60 PSF. New York, Long Island, I can see 25. New York City, 25 PSF. Okay, so I should not waste so much time here. I know that you understood this part, that ground snow load you will collect it from local design office, or if you Google it you can get better result. And I will upload you a PDF which will show many cities. Yes. Okay, so where we are? So we are in Rosie. Rosie or PZ? What your book says? Rosie? It's not Rho, it's P actually, lowercase p. So hopefully you understood this also. Simply where you are designing in that area, find your ground snow load. In Pueblo, typically 30. Denver, 40 for 45. Colorado Spring, 40, 35. Even in Colorado Spring, it changes. Left of I-25 to right of I-25. Left is mountain, lot of snow. Right side, almost flat, less. So every location it like is different, so you can find it. I should not talk more here. Now if I go to exposure or CT, yes, let us go how to find it, exposure or CT. Okay, this table, not this one. Oh, some other table from AC. I was actually looking for this table. What is this table? You can see now, table 7-1 in your ASCE, that gave us some numerical value, not the graph. See, Anchorage. I know that you know where Anchorage is. Alaska, south, not north. North is Fairbanks, Anchorage. PSF is 50, 50 PSF. I do not know where this city is. Cordova, oh, Fairbanks. Fairbanks is in Alaska also, north side, 60. 100, Baba. Cordova. In Cordova, it is 100. 100 means you cannot imagine. 100 means similar to gallery. What about the load in a gallery? So high. Petersburg 150. I do not think anybody live there or no. Should 300. Whiter. Where is? Oh, all these are inside Alaska. So Whiter, do not go there. In summer you will get snow. Okay, so if I go down. Oh, now I came to exposure. What is this? You can see terrain category, that means surrounding. This is surrounding, and this portion on top of your building, sheltered, partially sheltered, or fully exposed, is mostly fully exposed. Our building, we do not have any tree on top of our building, very rare. So most of our building is fully exposed. There is nothing on top of our building. Now what is category number A, B, C, D? This section will describe it in your ASC 7. If I do very briefly here, what is A? A means Denver, B means Colorado Spring, C means Pueblo, D means Sea Beach. I think that will give you the answer. What does it mean? If it is so dense, then A. If it is light dense, semi-urban area, Colorado Spring, B. C means there are some building, scattered building, not so congested. Even in Pueblo downtown, I will say Pueblo downtown is B. In Colorado Spring is B. Some offsite may be C. Say Pueblo Airport. Pueblo Airport area, there are a lot of buildings. Still though, that building is like is far away. One building doesn't affect other. There's a gap. That can be C or D. Up to your decision. When you'll go to one, obviously before designing, you will go there to see the surrounding at least one. You should go there. So Pueblo Airport, I will consider C or D. Now you can see that always considering D, C is better. D means sea breeze. The wind will hit the building directly. Now to know more, you can read this section, but I do not recommend you to read. It's very confusing. That means they will not give you answer directly. Everything is based on your judgment. You have to judge. Okay, so A is dense, B is semi-dense, C is not dense, scattered building, D means open to air. Air can hit directly. That is A, B, C, D. Exposed means like on top of your roof, if there is any shelter or no. Mostly fully exposed. Most of our building. Some building may be partial. Sheltered I do not see so much. So, oh no, based on this category, terrain and exposure, find your CE factor on 1.2, 0.9, whatever. Now, this is, so you can see C is not a confusing, very clear. Come to table, take a number. Always try to be safe. That is my recommendation. In your exam, I do not care so much what you selected. As long as you selected something, is good. And in your real life, you will go to the building and go to the site and examine carefully and then judge, and always try to be safe. That is CE. Now we'll go to CT. Now you can see T here. What is CT? Now CT, very brief or summary, always one. Why? Sorry, I should not say always one, mostly one. One means our normal building, that is one. Category number two, if you read, you will see structure kept just above freezing. That means you will always mm, turn on your heater to make the temperature always above freezing, above 32. That for this case is 1.1. This category, unheated structure, that means you do not heat it. It's agricultural storage type building. In that case, it is 1.2, that we do not heat at all. We never touch it. Just it is in the nature. For that case is 1.2. Other case is continuously heated. We heat it continuously. That kind of building, say greenhouse, that kind of building is 0.85. Now these all three are like non-conventional. Mostly it is one. Normal building, official building, it is 1. Okay, so if I go, hopefully you understood. Obviously it is from your ASC. Did I upload it? Let me check one more time. I told that I uploaded it in your Blackboard. Yes, ASC 7. I wrote here ASC 7 because it is ASC 2007 edition. 2016 is the latest one, but it is for buying. I did not buy because actually I did. It is better to buy, but they change it almost every 2-3 years. So and it is very costly. So how to buy costly, that they will change everything. But the concept they do not change. They change some minor values, which is needed to design engineers only. Even for learning purpose, old is also good. Same thing, they will just change the value. What kind of change? Uh, say small, say Importance factor, they may made it 0.85. They may make category 4 1.25. They can sense this kind of sense, but the concept is same. The number is also same. They did not change the number. Okay, so oh, I am talking so much. So this equation, hopefully you learn. It is flat roof snow load. F means flat, considering flat. Now your question is, what happens if it is sloped? And most of our building is sloped. How? Because most of our building is this way. There is a slope here. And in that case, what to do? No problem. In that case, your load will be PS, slope load. What is that? PF times CS. Simply multiply another factor, CS. How to find CS? Again from ASC 7, and it is somewhere here. Figure 7-2. 7-2 in ASC 7. Oh, what is time? 12:10. Yes, I have some time. I should not hurry or rush. Oh, how to find what we are looking for? CS. Yes, CS. The vertical axis is CS. Horizontal is your roof slope. 0 degree, 30 degree, 60 degree, 90 degree. 90 degree is not possible. You know that. You cannot make a building with 90-degree slope. No. Common is 45, 30 is very common in Colorado. And when there is no snow, say where even in Asia, Australia, Africa, there is no snow. So they make it minimum 10 degree, 5 degree just for the rain. Oh, now how to find it? So first category, if your CT is less than 1, CT is 1.1, CT is 1.2. And most category is this category. CT is 1 or less. So 1. If it is this category, if your roof slope is 30 degree, go top. This line is for unobstructed slippery surface. That means the surface is very slippery and there is no obstruction. If this is the case, now what does it means? It means if your roof is very slippery type, that means it is not shingle. If you use other kind of material, I forgot the name. If it is shingle, that commonly we use in our building, the black asphalt type shingle. It's not asphalt, it's shingle. That kind of is this category. If you use the smooth type surface, then it is this category. So mostly you will use this category. So if it is 30 degree, go up. You can see here it is 1. If it is 45 something, 60, come here, 0.2. If your slope is high, coefficient is less because all the snow will slide. So now you can see here, you have the resource to find CS. So if I go back now here, nothing to memorize, nothing to understand so carefully. No, is gross, vague. Nobody will tell you that if we use this versus this, it is a mistake. No, it is a guideline. And even what does unobstructed slippery surface exactly means? Nobody. I do not know anybody knows. Anybody knows exactly? No, it depends on person to person and engineer to engineer. Everybody will judge differently. But these tables are constructed in a way that it will be safe. So whatever value you will use, you will be in a safe zone, no problem. Okay, so if I come here, what I did here so far, in your book, article 2-10, I tried to explain this article 2-10 first part. Now this article is so big, we need at least 2 more classes on this snow load. Now I spent 3 classes at least in this topic. Why? Because we are in Colorado. Colorado snow load is very important. Rain load, we do not need to worry about rain load. But in Colorado, snow load, wind load, earthquake not so important. Even earthquake also important. but I cannot cover everything in this class because then I cannot start the steel. Even somebody may ask where is the steel. Yes, we need 3 4 weeks to go to steel. um, and the reason this part is not covered in CET 316, we cannot. Oh, let me turn on video, it's so long.